Hey guys, welcome back. Although I say back, this is sort of a new series. It is a continuation, but as you saw in the title, C, the language I've been working on for a while, is officially dead. Now, it's not really dead per se, but more just renamed. If I'm being completely honest. Basically, when I first had the idea for C, I was deep in Python and I was really loving everything in Python. And I just had the idea of what if we had the language C, like the letter C, the original C programming language. And it was the exact same language, but it simply looked like Python. Because, in my opinion, at that time, that was a good thing to strive towards. Wouldn't it be nice if you could write C code in a very sort of just like syntax sugar way that doesn't influence performance at runtime? And so that was the original idea that got me into making a language. Since then, the actual idea for the language changed an absolute ton. But like I've said, the original idea was to just write C in a different way, which is why the name C, SEA, fits so well, is because it's C just written differently. Like, that's a good tagline. But over the last few years, I've sort of just been indecisive about what I wanted my language to end up being. And it's moved away from being just a one-to-one clone of C, like a syntax upgrade of C. So the name didn't really fit anymore, but I was just holding on to it because I didn't really have a better one at the time. So the name I've currently settled on, at least for now, is Zenith. There's not really a good reason. I just had a discussion with ChatGPT about different names and stuff. I looked at a handful of them that were interesting, and I tried to look if they existed anywhere. I mean, I guess I can kind of just do that live right now. If I just search like Zenith language as an example, you don't really see anything, right? Like other names and stuff, you'll get something, even if it's obscure, but here I'm like Zenith language, and it's like, there isn't really, as far as I know, a programming language called Zenith. And that's an important, piece of making it's an important part of deciding on a name is whether other things are using it already or not. And as far as I can tell, nothing's really using the name, so I figure it's reasonable. Not to mention, I kind of like that it starts with Z, kind of like Zig, just because it's always going to be like last alphabetically, which hypothetically is useful for certain things with files and names and stuff. Also, I have a few reasonable file extensions, so obviously there's .z, which I can't really use because that's for compressed files in Linux or something. I could do .ze, but how would you say that? You would just say .z, right? Like, or .ze or something weird. And so I think that's too ambiguous, plus it doesn't, like, it's too ambiguous in pronunciation, plus in visual. It's like .ze, that doesn't really mean anything. So the two I'm settling on for now are .zen, which kind of implies something to do with like yoga or meditation or something, but I don't really know if that's a used file extension. I think I looked and it isn't really. It hypothetically could be used in the future, but I don't really know for what. But I think I'll accept .zen will be preferred. I might accept .zenith as well, but I think .zen's reasonable. Just 3 letters to represent a file name. It's not too big of a deal. It's not like you have to type something absurd every single time. And so that's sort of where I'm at in terms of naming. Now, another big problem I've had, the reason I've constantly done so many rewrites, and in fact I can show you, this is just a handful of them, by the way. If I go to my Python folder, do I even have a Python folder anymore? It's probably in Legacy, where you can see tons of junk I've been working on, but you can see, for example, C compiler and interpreter, C programming language, original Legacy, and yes, I am using Git, but I'm not good enough at Git to avoid doing these stupid, like, noob, like, version handling stuff when I do a whole, like, rewrite. And then language overhaul legacy, C to C transpiler, C transpiler prelexer. And so, unnamed compiler. So, like, I've had tons of iterations of this. I did a lot of work in Python, and it was fine. It was interesting, but it was just so slow. Every single time I ran it, it took like 2 seconds to start running, and it was just like a pain. And so I decided I should write in a fast language, so I rewrote it in C++. Is that going to be in here? No, there is an LLVM thing I sort of messed around with. Hyde and Jekyll were two other language ideas for a little bit. But I think in here, yeah, you'll have language, which was the second one, probably in C, which is another one. So I worked on it in C++ for a while. Back, can I see? The ultimate flaw, though, that I had with C++, it wasn't even the memory management. I wasn't even using smart pointers or anything. I was just doing like bare bones references and pointers, and it was fine. It really wasn't a big problem, but the real flaw with the design that made me stop doing C++ was the fact that it was OOP. And I didn't realize this at the time, but obviously, just because I'm fresh out of like college and I've done a lot of Java and stuff and a lot of Python, I'm very OO sort of focused in terms of how I program, which isn't inherently bad or anything, but it means I over rely on it. And so one of the consequences is, if you followed my previous tutorial series, is I represented each expression in my language with an entire class, which isn't a horrible decision. But the problem is when you're doing that in C++, then you have a CPP file for every class and a header file for every class. And it's just a nightmare to maintain, because if you want to look at like your parser and your expressions, then, oh great, now I can look at this. What's a single expression? It's just this. I need an entire file for this because C++ is stupid. And you need to write headers for everything for no reason. It's so stupid. And like, this is one of the big reasons that also inspired me to keep going with my language. Because I do enjoy writing C. C isn't that bad. It really just needs a handful of things. C++ was a mistake. Adding classes to C was unnecessary, in my opinion. What it should have been was C with namespaces. Like, that's all it really needed to be. Maybe a handful of other things. Because namespaces is really where C just falls apart. It is so hard to do anything. Like, you don't have any visibility modifiers. You kind of have like, this can be static, so it exists in this file only. And I can like hide data and that's it. But like, I can't just say this exists in this module. There's no like modules. And I feel like that's where the industry kind of went awry. But I'm kind of just parroting a video I watched, if I'm being honest. So I don't really want to just like copy that video. But it was essentially saying, it was like the whole history. I think it was a video called Why Functional Programming is Not the Norm. You should check it out. It's really interesting. And it basically, I believe the person's conclusion was, in fact, I'll try to remember to either put a card or put in the description, because I'd hate to just like rip off the ideas. But the idea is basically there was a language called like Modula, which was one of the earlier language that introduced modules in programming, and sort of like this compartmentalization or encapsulation, as a lot of people would like to say. This way to just build a module, to put code in the module, and to have modules be separate unless you need them to explicitly interact, which is a great idea. But the industry sort of decided, we're going to do that through classes. But we're going to make classes our modules, and that just isn't really that great, in my opinion at least. And so you can see just the expressions, all of these files, and then the statements, all of these files. And I have all the declarations, look at this. And these are just the header files. I had an equal number of CPP files, because that's just sort of what happens when you make the decision. I want one class per file, and I'm writing in C++, which means I need a header file for all my classes. And every sort of expression gets its own class. This is the consequence, and it was unmaintainable. So what I decided to do was learn a language called Kotlin, because I don't know, I was just like really interested in it for a long time. It was just sort of in the back of my mind. I'm like, I remember hearing about it. It's basically just a version of Java that's just better. And in my opinion, working with it so much now, it basically, as far as I know, because I haven't worked with Groovy or the other JVM sort of languages, but in my uneducated opinion, like I've mentioned, Kotlin is the best version of Java, which I think is the best way to put it. If you want to write Java, Kotlin's just the best. But Kotlin as a language is fundamentally flawed because it is Java, and it must be interoperable with Java code. which is a good thing if you're writing Java and JVM code, which makes Kotlin a great language. But fundamentally, it's just always going to be worse. I know that there's a Kotlin native compiler, but I don't know how that actually works. Because the issue with Java, the big issue, honestly, other than the stupid syntax and all the repetition, it's the damn built-in class hierarchy for everything that's so unnecessary. Like, you have a million different types of lists that all have their own classes for things. Interfaces are fine. Having a list interface is good. But having just so many... If you ever look at, like, the built-in Java standard library sort of thing, and you look at the class hierarchies there, it's just nonsense. It's just, like, way too much. And, like, that... Even what I'm worried about with the Kotlin native compiler, which I haven't used, is... How is it going to compile something like a mutable list to machine code? Is it just going to like do a copy? It's going to like mimic what the JVM does? Because then it's inherently like just flawed because it's stuck in that like class structure that's just wrong. Wow, I sound like a Marxist now that I'm saying class structure. You know what I mean. So I don't know. I mean, I could be like just misinformed, and maybe what it does is it's actually really clever, and when you use a list, and it knows that you never append to it. It just writes an array in memory or something. But what I'm imagining the native compiler does is it just does a lazy sort of copy of the JVM as like a binary file. So if you use like a mutable list, it will write the entire class into the binary instead of like doing what you really need it to do, which is like one tiny thing. You know what I mean? Because when we use mutable lists, all we want is like an array list, essentially. And array lists aren't that complicated, but when you look at Java and you have all this hierarchy with all the functions it needs and all the properties and stuff and all the implementation, it becomes a nightmare. But anyway, that's sort of its own discussion. I've been very happy with Kotlin so far. And I did I even show? I think I started here. I've written a few things in Kotlin as well. I probably have some in Legacy here. Do I? Yeah, Zenith compiler old already. Yes, I already have an old Zenith compiler. I don't remember why. Something. I changed something. Oh, right. Because, like I said, OOP just didn't really work for what I wanted it to do. It's okay. So what I did was I'm trying to experiment with a bit more functional. I looked into functional languages as well, pure functional languages, and I just don't like them. Languages like OCaml and all the other ones, like, they're fine. They have good uses. And I'm sure if I learned them, it wouldn't be a big problem, but I just really prefer procedural. I really prefer the way that imperative procedural code looks, because to me it is just so much more readable. And so what my goal is, I want to essentially do procedural functional programming. Which, that's its own sort of discussion, right? When we say OOP, that means so many different things. We could be talking about Smalltalk OOP. We could be talking about Java OOP, which is probably what most people imagine. When I say OOP, what I kind of mean are all of my logic is put inside of a class with a shared mutable state on each object. That's basically what I mean. I mean, you have a class. I can probably give an example in here. Because as I was experimenting, I want to rewrite things different ways. So if I write this Lexer class, even this one, this implementation, this was a really old one. This was really bad, but you can kind of see what I'm getting at here. This was very OOP. I'm not even using inheritance because, you know, prefer composition over inheritance. Even the design patterns book or whatever recommends that. So anybody who just runs to inheritance, you're kind of doing OOP wrong, even by OOP standards. Inheritance is useful sometimes, but composition tends to be better. Anyway, this is a very OOP design. Why? Now, this sort of context way I'm representing this, this was me beginning to make things functional, so I was passing around a context object, but it was kind of the same idea, right? This context has mutable properties. It has a var builder, something that can change. This didn't even have to be a var because I can just call clear in this, but I discovered that later. This was very old. but it would have like a position. And basically, as you make tokens, you just modify this class using functions to modify the shared state of the class. And that's an OOP way of doing things, which isn't inherently bad. But what I'm just experimenting with is trying to minimize shared mutable state. In fact, trying to minimize mutable state at all, because while it is useful, especially for performance reasons at times, it's best to try and keep functions isolated from one another because it makes it so much easier to change them. And when they're constantly referencing the same mutable thing, that becomes very hard and there's a lot of complexity. OOP is good at hiding complexity. You can encapsulate it into a class that deals with it, but doing this more functional approach, I should say, helps get rid of complexity to begin with. Now, obviously, I'm not doing pure functional. I'm still writing in Kotlin, although Kotlin's okay for pure functional, I suppose. It does have a lot of functional principles in it. I guess I can sort of demonstrate this. So before, when I was handling faults, I would basically throw an exception if there was a failure and I would catch it. But now I'm sort of passing faults, I'm handing them between things. Although this isn't going to be very demonstrative, it kind of will be. So for example, you'll notice I basically just have a bunch of functions that does everything. Here I have just like a class to represent like statuses, because what we're looking at here with this main function is essentially the CLI tool, the actual like what I used to write in a bash script, but I realized it's probably better if I just keep it in Kotlin, because like Jonathan Blow has said in the past, like scripting, it's like you tend to just end up doing programming, so you should just use a programming language instead, which is mostly true. So what I have is, you see here in documents coding Kotlin Zenith compiler, I can do something like Gradle wjar to build the jar file. And then what I have is an alias in my ZSHRC called Zenith dev. So this is just to represent what I want my actual process to look like. In the future, you would just say Zenith. I'm doing Zenith dev because I'm specifically using the development version of the code that you see on the left on my system and not like an actual version. So, for example, this is what I'm working with so far. It's like a normal CLI thing. It tells you usage. You say Zenith followed by a command followed by any optional args. And what I have right now is Zenith dev help. Obviously, just for compatibility and stuff, you see here I accept help, -- help, and -h, just because those are very common things. Even though I like my commands to be whole words, I'm still going to accept this just because it's so common. It's that sort of get-op like way of doing things in Unix. So for at least the help command, I'm allowing it, because it would be very stupid if when you say a command -- help and like nothing happens, you know? It's like, it's standard enough, I'd rather just allow it. So what you can say is Zenith dev init, sort of like Gradle, but it's like very lightweight. And then I can say like, what would be a good project name? I don't know, my app. And it creates the my app folder. And then if I actually look in this and I want to show everything, what it produces is source folder, a lib folder, a bin folder, a git ignore, which I guess I can print out. All it does is ignores the bin folder, obviously, and a zenith.config. Currently, I'm not doing anything with the config, but in the future, this could be like, you could specify like which version of the C compiler do you want to use, because I'm going to transpile to C, or other sort of project properties, etc. And how I want this to sort of work is, instead of having to deal with header files when in doing libraries and linking things, what I'd like to do is something just smarter and be like Zenith, and then you could do like install, and then you could do a package name, and it would work sort of like npm. I have no idea how I'm going to implement that, but that's far in the future. But this is sort of the structure. For a long time, I wanted to make my thing work more like GCC, where you sort of just give it like a name of a file and a bunch of files and it will work. But I just don't like that way of programming. I think it makes so much more sense, because when you do that, you need a make file, inevitably. Like you inevitably need like make or cmake or some other build system. So I'd rather my whole language just have some dedicated build system built in. And a lot of languages will call it something else, like Rust has like cargo, OCaml, I forget, like all of them have something different, like Python has pip, JavaScript, specifically Node has npm. For now, I'm just going to call mine with the exact name as Zenith, because to me, it just like, it doesn't make sense to me, really, to separate the idea out. Because wouldn't it be nice if you could just say Zenith init, and then you could code, and you can Zenith build, and Zenith install, and just use one command for all this stuff, and you don't even have to look at documentation, because you can just look at the help command to see the usage information, and you can just know what you need. So now if I go into my app, I can sort of show the current state of affairs. I also aliased vim to vim dot because I often would miss the dot. I'd press enter first, and then it would open a blank vim screen that's completely useless to me. I basically always do vim dot, and actually it's neovim, but anyway. So I can go to source, and I can just do something like test.zen, and this is like, things are very much not really working yet, but I can just showcase a few things. So what I can do is 6 plus 32i minus, I don't know, 5 divided by 2. Something like that. And I can also show you, because most of my lexing's working. I don't have all my keywords or punctuators yet, but most of the lexing's working. So for example, I can say, this is an expression, that's too many S's, followed by, I don't know, a bunch of spaces because I can. And then I could do like 5 minus 2, new line. Yeah, that's fine. Although I can probably nest it again. I'll do a string that has something like this, just so I can represent that this sort of nesting works. And then what I can do is I can say zenith dev build. And for now, it's just printing out all this information because it's not complete. But I want to showcase how I'm building my tokens. So as per usual, it's represented in a very similar way if you see my previous videos. But one clever thing I did, because parsing strings the way I do them with my string templates is kind of hard, but it's really hard without a shared mutable state, because previously I had to represent like I'm at the start of a file or I'm at the start of a string. And so the token needs to remember that. That way I can actually parse like expression, like these templates. Because the issue is if I print out source slash whatever, you can see like, how does it know? Because these characters are ignored. So if it sees this is a string token, and then I have to do extra tokens because these are separate, I want to parse them exactly like everything else. So it would have another string token, and then it would have these tokens, and then another string and another string. So how does it know where one string starts and ends? Like, because you could have a string split by multiple tokens. So the solution I've come up with now is when I build a string, I append just a specific token that is a string start token, and it's written, it's just displayed like this, sort of like an HTML sort of style, just to represent this is one string. And that is right. That is this string in here, the string that's quote 5 minus 2, and you can see it actually gets the actual tokens. It uses the exact same lexer as everything else. I don't need a separate sort of string interpolation mechanism. It works exactly the same as everything else, which is why, unlike Python, because I thought Python F strings were like the top of the game, you know, they're very good, where you could just write like F, and it's like var name. Like, that's very good. But being able to say, firstly, just being able to do this is actually better, in my opinion, because it's just so simple. But the real thing I love about Kotlin-style string templates and interpolation is you can just leave double quotes inside of your strings, and it doesn't care, because it's interpreting these as actual tokens. And you can see that there's no problem. In Python, you'd have to do a bunch of slashes, and like, you could argue it makes it more readable, but I argue it actually makes it less readable. I don't think something like this is actually more readable. Like, is that really more readable than like this? If you have good syntax highlighting, right? Like, this to me on the right just looks more readable than the thing on the left because you don't have all the slashes and stuff. so long as your syntax highlighting knows how to handle that, which that's its own problem I'm going to have to deal with eventually. So, like you see here, start of a string, end of a string, but all of this itself is nested inside of this. So I'm hoping that these tokens here that exist, that are easy to make, if I'm making a string, I just plop one of these. If I finish, I plop one of these. Hopefully those should make parsing a lot easier. But otherwise, this is very similar to stuff I've done before. One awesome thing I did with tokens, and you can see I sort of have the same sort of faults as before. If I go into my tokens, something I did before in the past is I used to store the entire file as a list of lines. Now, why would I do something so stupid? Because what I wanted is a message like this, where you can mark a token as being problematic, and then it can print the entire line that it's on, and it can show you exactly where the problem is. This error is happening because I didn't handle new lines in my parser yet. My parser is very weak so far, but you can see it's sort of working. It makes additive expressions, primary expressions, specifically numbers in this case, multiplicative, and it's like it actually is working correctly. Except it doesn't know how to handle new lines yet, which is why we get an error. In this case, a failure. But I'm handling things differently. Before, I used to store every single line in a file as like just a piece of memory, and each token knew which source line it came from, which was its own problem because now tokens are limited to one line. And I'm storing the entire file just in case there's a problem. What I realized is I actually only need 3 pieces of information. I only need the file name that the token came from as a string. I need the line it came from as a number, and the character in that line as a number. Because what I can do is I can just, if there's an error, which there will not always be, I can simply reopen the file, go to that position and read the line, which makes a lot more sense to me. Instead of storing, hypothetically, many files in memory at once, because this compiler may compile files asynchronously, you would have to store every single file as a list of lines for the length of like the program because they're attached to the tokens. That's just stupid. Now I can just have a string representing the file name and 2 numbers. But actually, you don't need 2 numbers, because why do I need the line number and the position in that line when I can just have a position in the file? I can just count from the first character to the last a number. And so a token can be represented as the file name, where it begins in that file, and where it ends. But actually, you don't need where it ends, because you can calculate that based on the length of the string that the token has. If this token is 3, so if I have this position, I immediately have this position based on the length. So actually, I can just store the file name and the position. But even better, I don't need to store the file name because the process itself keeps track of which file a token came from. So each token, of which I'll have tens of thousands, now only needs to be represented with a single position number. And in this case, I'm using a unum, which is a custom type, because, well, I could have just used an unsigned integer. But that's the thing, that's 4 bytes for every token. But, like, if I were to use a short, for example, a ushort, that could store, like, assuming that you had 80 characters per line, and I mean 80 characters, not like this, you know. I mean, there are spaces all along here 80 characters long, or some other symbol. If you had 80 character long lines, you could have like 800 lines be represented using a ushort. But 800, I mean, that's a lot, and most files won't come across that. But it would be nice to not force, you know, people to like, yeah, sorry, my compiler just doesn't handle your file because it's 890 lines long. So what I did was I started exploring what are called typed unions. at least what I'm calling them, and you can represent typed unions using sealed interfaces and classes in Kotlin. So what I have is a unum, and what a unum is it could be one of three things. The idea is I wanted a class that could dynamically choose, well, if this number is small enough to fit inside of an unsigned byte, then use an unsigned byte for memory. Or if it needs a unsigned short, use that. If it needs an unsigned int, use that. I added in ubytes just because I can, but they're only going to be useful for the first like 3 lines of a file. But still, it's half the size of a ushort, which is half the size of a uint. So adding like 2 extra lines of code to do that, that's fine. That's fine by me. Because we're going to have so many tokens. So what I have here is this sealed interface, which means by making it sealed, I'm saying that these are the only unums that exist. There's no other classes that implement unum. These are the only ones. And so what I can do is something like this, using when expressions to represent pattern matching. And I can just say, if this is a ubyte, then I can get its value by just casting it to a uint. Because when I'm doing the calculation of where something is in a file, I can represent that as a uint. I just want it stored in the token in the smallest way possible, because I'm going to have tens of thousands of tokens in a file, and each of them is going to have a position. So if most of them can be 2 bytes long instead of 4, that's a huge benefit. And so I just added a few convenience things like adding them together, adding an int to them. And how I do this is I just call new on a unum if I want one. And then I basically just check. If the numbers is smaller than the maximum ubyte size, make a ubyte. Same thing for ushort, otherwise uint. I could add a ulong, but I figure uint supports like 3 million characters or like 3 million lines in a file or something. So I figure if you're past that, that's your own problem, not mine. Even though it's easy to add a ulong to this, I just don't think it's really worth. So that's one of the typed unions I've made. Here's another one I've sort of been working on, which is a none or more. It's like an optional, except it can represent a list as well. So you have none, which represents nothing. You have one, which represents a single thing, and you have more that represents a list. Because sometimes I'd rather not make a list of one item or even pass around an empty list. The empty list isn't too bad, but making a list of one item feels wasteful. So I'd rather just do something like this. And it's sort of just, it's just an interesting way of doing things. But this is also sort of experimental. So now I can sort of, I've also made improvements to my source file logic. Because of course, even though I'm writing this in a functional way, you can't fully get rid of mutable state because the computer itself is fundamentally non-functional in the sense that, like, if you're interacting with I/O, that can't be done in a pure functional way. It's purely like side effect. So I tried to minimize it by representing just a single class to handle this. And what I'm doing so far is basically I have a buffered reader to represent the file so that it can efficiently read parts of the file at a time. But I also need a separate buffer in order to peek at the file, which previously I would have called read string or something. Basically, I just want to look at what comes next without actually affecting the state, because that makes lexing very useful. Being able to look ahead is actually so useful. So what I did was I basically have a buffer of like a very small size. It's usually just going to be like 3 characters long, and I'm using a deck just so that, because I'm always going to be adding. Why did I choose a deck? It's because I'm going to be removing from the first one all the time. It's something like that. But basically, it just handles a good amount of the logic. It adds. I split my previous take method, which was a very cool thing that had default arguments that was very cool, into 3 things, because what I realized is I never used all 3 of the arguments at the same time. So I'd rather just use function overloading, because again, like I said, I started this all in Python, so I didn't have access to function overloading. So a lot of the stuff I the decisions I made was because it was a very Python design. That's why for the longest time I never even used private to represent like data in my classes, because in Python you didn't have that, so I was like, I don't need this. But yeah, and I represent these using a read while, and I just pass in a function that returns a Boolean. And so what I can do is, on each check as you're reading, I can say, well, read until the buffer is like, well, read buffer's its own thing. I don't really have to go into the full details of this. You can see I'm also using another lovely Kotlin feature called extension functions, something like that, where I'm basically just adding methods to objects that already exist, just for convenience. So stringbuilder.empty, this just exists so that I can clear the string builder and get the value at the same time, instead of doing it in 2 steps, because that's kind of dumb. Although I actually only use this one time, I think, so I probably don't need to even make this, but it's whatever. And then I also have a buffered reader read char, one that returns a nullable char. So instead of having to check if char is -1, I can just have this do it. It reads a character. If it's -1, it actually it returns null, otherwise I cast it to a char. Just because that's the more Kotlin way of doing things. The reason for the normal implementation is just because that's how Java works. If Kotlin did it, like I said, right, the problems with Kotlin is that it's Java. I'm pretty sure if Kotlin implemented this from the ground up, it would be using nullable types for these things like this. Probably, although that's not necessarily true. I don't know. But yeah, that's like most of the stuff for like the from the bottom up. I like can't talk right now. Previously, I had like a class that represented faults, that an object would be passed around between the stages. Now, similarly, I have a sealed class here for representing faults, warnings, errors, and failures. I'm doing things this way specifically just so I can use the like when expression. I can say is a fault.warning, or is an error, is a failure. And instead of having classes that do things, here's my interface for things that can be have faults, which I'm calling faultable. All they have is a field or property, depending on how they implement it, called fault position that returns a uint range. Because that's all I need, right? All I need is the starting position in a file and the ending position in a file, which I'm representing as a uint range. I'm using fields for this, so it's just a function, meaning it's not going to actually store the entire range for no reason, but when it's needed, it can calculate it. So, whoops, if I showcase that by going into my token file, you can see here, I override it, and I construct the uint range. The start is just the position, and I'm saying .to uint, and then I'm taking the start, and I'm adding the length of the thing -1. And I'm subtracting 1 because this is inclusive. So, and then I'm just returning a uint range. And I can do a similar thing for my nodes, and I think I actually have. Yes. So basically, the way oh, I haven't even talked about how I'm representing nodes, so let's probably just focus on faults again for a little bit. So I just have a function instead of a class that just says print faults. You give it what file it needs, and it takes a list of faults. Like, that's it. It doesn't need an entire class to dedicate the logic. I can just have one function to do what I need it to. If there are no faults, it just does nothing. Otherwise, it opens the file and it uses it immediately. It maps all of the lines to add new lines back in, and then it will actually go through and it will print the file lines. And here is where I do the like basic logic, right? This first bit here, this first for loop, just basically it moves its way through the file, which I'm now representing as a list of strings, which is fine, right? I can read the whole file as a list of strings if there's an error when I'm reporting the error instead of the entire time. And here, this will get its way to the first line because it could print multiple lines, right? Like, you could have a node like this one, right? If this node has a problem, it has to print all of these lines. And so this first for loop just seeks its way to where the first line is that it needs, and then it will just iterate through each of the lines as it needs to sort of just print them out. And like, that's it. That's all it does. I don't need a whole class. This whole file is just 62 lines, which is probably more than it was before, but it's just like, it's a single public function and everything else is hidden. Although I'm sort of using packages badly because most things are just in the Zenith package, but I'll refactor that as I see fit. Because for now, I do want everything to just have access to this without actually having to import anything. So now I can sort of show you how I'm using my Lexer. Previously, I would have had a class, sort of like I've shown. I can probably show you again, because I have so many versions of it. If I go back into Kotlin and C compiler app. Also, I didn't even discuss this. I did experiment with Antler for a bit, and it was fine. I even wrote most of my grammar in it, and it was really interesting. But one, it's just so OOP by default that you're just stuck in. And two, it's really hard to make things work how I wanted it to. I think the nail in the coffin for me was, I know I could add like an error listener or something, but I just didn't think I could do errors like this, where I could do like good errors the way I wanted to, where I could like, each token knows where it is and stuff. And like, I just don't think I can modify Antler easily to do what I wanted it to for errors. And like, good errors are just so necessary for a compiler. Especially for me writing the compiler, having to debug it. But yeah, if I go into my previous Lexer, you'll see I had a data class. Data class because I didn't know why I'd use a data class over a normal class. I didn't really understand, but now I do more. But basically, I had a Lexer. It has a list of tokens, which you'll notice an array list. It is a mutable list. This was back when I explicitly used array list instead of mutable list of for things. But yeah, it would have a function called new token, which would modify this global thing. And then you would come in here and it would have all the context it needs. It can check while the file.next is white space. And all these methods just share everything as needed, which is super convenient. It makes the code pretty readable, but the issue is it's just like so interconnected. And I'm not even saying that this design's necessarily bad, because it's a pretty good design. But I wanted to experiment with a more functional approach, and I also really like this design too. So the first things first, when you're doing functional stuff, you have to represent your data better using like more clever types, because your functions need parameters. You need to list all your dependencies as a parameter, which is its own thing. And then you have to return your state. Your state isn't like something that everything has access to. It's more just like, instead of everything having access to the state, it's more like the functions hand the state from one to the next. That's a bit closer to what it's actually sort of doing. So what I've created here is a result type. I considered using the built-in Kotlin result type, which is very similar to a lot of other languages, where it either returns a value or like an error. But that's not really what I wanted, because some things needed to return no tokens. Some things, specifically the string lexing, need to return a list of tokens. Some things, but the thing is, even if you had a failure, you still need to return a token too. So I had to construct something like this where I'm using my none or more. And you can make a result using tokens and false. I have two convenient constructors here. One where you could have a null token, just so your like result pass in like nothing, it doesn't matter. And it will figure it out. It will just do this. Or, for convenience sake, every single fault in this class, in this Lexer, in this file, every fault will be pointing to one token. So you don't actually have to pass it in with the result. You can just pass in the fault, and I can just grab the token from the fault. And then I can also store the fault. And then I have some convenience things to check if it failed, because if it failed, that is the representation of a failure instead of an exception that just cascades up. I need to do that manually, so I can just check, did the result fail? And if it did, then I can do something about it. And this is a convenient way to check. I can check if any of my faults have failed. And previously I was using lists, but I recently changed this to none or more. So I implemented any on my none or more, which is pretty simple. It's just going to check, if If it's none, return false. Otherwise, you just apply it basically as you'd expect. I also have a check if there's tokens and if there's faults. I have a way to add these things, which it's not ideal because I'm adding immutable data together, but it's okay. It's really like not that big of a deal, I don't think. And then I have a way to just check if the last token has something, because I need to use that in like 2 places. Because again, like I said, previously I could have just reached into the list of tokens that's stored in the class that everything has access to, but now I don't, so I have to be very careful about where I pass things. So I have a function called tokenizedFile. It takes in a file path, and it returns a result. The way I've done things, every function can return a result, but even the like public-facing interface can just return one of these results. Like, that's totally fine too, the way I built it. And you'll notice here, I do have some mutable state here with this result, because basically I just need to constantly change it. Where first I open my file as a source file, and I have an empty result, and then while I'm not at the end of the file, I can make a new result by making a token, and it needs 2 pieces of data. It needs access to the file, and it needs to know if I should save the next new line or not, because when I make a new line, that's its own like nightmare, and I don't want to make a new line every time I see a token. I want to make new lines only when it's necessary. So you'll see, for example, even if I put like 2 new lines here, like after this, it will only take 1 token. And in fact, I just recently realized like new lines inside of string templates are completely unnecessary, so I just got rid of them. I didn't even make it, because when I call make token, I just passed in false for whether or not to save the next new line. So I can just say, make the token, get the result, and if it failed, then we return result plus new result. Otherwise, we just add. That seems stupid to me. Why wouldn't I just do result plus equals new result, and then what I can say is if result dot failed, I return result. Although it's actually probably smarter to check if new result failed, because it's always going to have a smaller list of faults to check. So hypothetically, that's more optimal. Not like it really matters, but that, I mean, I'm going to add it anyway, right? I don't know why I had the previous. Sometimes you just write things, right? That's like, why would I do it that stupidly? But yeah. And then if we reach the end, I append an end of file token. And then I use dot also as like a defer here to close the file, which might matter, I don't know. And then we get into like the private implementation. And I have like these 3 helper things to represent making warnings, errors, or failures. That way I don't have to pass in the fault label of lexing to attach, because you see here it says parsing failure. I don't want to have to write that every time I make a warning. And then I have a function that just makes a new token, which is a bit more convenient than working with the token class, because like I said, it needs a unum to represent the position. But actually, I don't need to calculate the position myself. I can just give it the file, and then I can just subtract the length off of the current position of the file at the end, and it can figure out where it began. And so I don't even have to do anything. I can just give it the file, the type, and the string, and it can calculate the position for me, which is super convenient. And then I can make a new fault token, which is even simpler because the type is none. So I can just give it the file and the string, and it will do everything else for me. Previously, I was like ignoring spaces and then making a token, but I realized I need to literally just always do this, and then if you're at the end, or if it failed, you can just return the result. And then I have my small little statement here, which is, again, it's very similar to what I had before. I could probably open this up for the 9 millionth time, and if I put this over here temporarily, get away, and if I go to here, you can see it's very similar. It's like I'm ignoring spaces, but now I'm just explicitly checking, like, am I at the end of the file? Am I here? And this is also more verbose. I'm reading spaces and comments, because read represents that I'm moving the file pointer around, but I'm not actually, like, doing a token stuff with. But here, it's like, yeah, make end of file thing, etc. But it's very familiar. And then if I fail, Then I make a new fault token, and then I return a result with a failure token unrecognized symbol. And that's sort of like how it's doing things. Instead of previously, I would have just thrown, I literally could just pull that back up again. I would have just done this. I would have thrown fault.fail, token unrecognized symbol. And I was also printing out the token string for some reason. That seems really redundant given the error message, but yeah. I'm not going to go through my entire lecture. I just want to sort of showcase some of the interesting things. One decision I made is new lines are tokens in my language. So rather than just make them with the space and comments thing that's supposed to just ignore stuff, if there's a new line, then we just stop and then it comes in here and makes a new line. So make new line, for example, it needs access to save next new line because it should only save a new line if this is true, like I've mentioned. Some examples of new lines I ignore are new lines at the start of a file, I ignore. New lines following another new line are all ignored. So there's only one if I put like 30. And new lines inside of string templates are ignored. Making numbers, it's a bit similar, but I've sort of changed my pattern on that, but that's its own sort of discussion for another day. Punctuators, I've just made into a loop. And you see here I'm utilizing my file.peek. And I can do this sort of dynamically so that if I add a new punctuator into my grammar, that's like four symbols long or something for some reason, this will still parse it just fine. Because it's just going to go, it's going to check the longest possible size down to 1 until it finds a valid punctuator. Otherwise, it will throw an error I never really thought about before, which is that you could have an incomplete punctuator, which is the situation where, imagine your language has a double star operator, but it does not have a multiplication operator. Like some weird thing, right? Then, if it's looking for punctuators, well, stars are valid punctuator symbols. So it was going to check, but it's never going to find a single one of these is never going to match to anything because that doesn't exist in your language. So this is what that error is for, is when you have an incomplete punctuator, which is essentially you have punctuator symbols together, but they don't themselves mean anything. And I have a very simple make identifier keyword. Like, look how small this is, right? I get the string by reading these chars, because previously it was all sort of implicit, right? If I look at my make identifier, which was also pretty small, I still had to store the string because I needed to check whether it was a keyword or not. But sort of for other things, if I look like here, when I'm making a string, I can just take things from the file and it will just add it somewhere, right? Like something else is dealing with it. But here I have to build things myself. So I have to make this string by hand. So for example, when I make a character, I'm using a string builder. And instead of saying file.takeChar or whatever, I'm reading one character and putting it in the string builder, and then I'm appending the string builder to do it. And it's a lot more explicit and imperative, while still being very functional. Because even though this string builder is mutable, it only exists in this function. So it fundamentally doesn't really matter. I'm using a string builder for the sake of performance, because that's going to be better than adding strings together, hypothetically. So, yeah. And you see, it's like having these results, it's actually really useful. Like, it's not... It was really hard at first to sort of wrap my head around how to write code this way, because obviously, like I've said, I'm very OOP minded. But it's actually very sort of natural to write things this way, and it's not that bad. Like, it doesn't look significantly different than previous implementations. And I do apologize that this is really small. I don't think I can really worry about that right now. But for example, in make character, it's really like not that much more code. Like, this is such a larger font size, but these both are like just about this big. Like, it's not really that crazy. Give me that back. I want to take a look again. And I also had the pattern here, but I moved that into grammar. And then I take the single quote, I check for other stuff. Here I'm using a when expression to simplify things. But all in all, it's like the same basic logic. It's just written in a different way, and I think it is fundamentally a better way because I can make a change to this function and it's not going to influence anything. Like, technically it is because it's going to be reading from the file, which is modified and shared everywhere, but that's the only thing that's being shared. I can call new token in here, make failures and stuff all I want, all day long. What matters is what I'm returning as a result. I can make 1,000,000 tokens in this file and return one of them. And as far as everything else is concerned, I've only made one of them. So for making strings, I also did something clever. I was able to merge multi-line strings and normal strings into one thing. As a result, it's a pretty large function, if I'm being honest, but I think it's still better than writing it twice because let's see if I did strings at all previously. Make string. That looks very, very simple. I don't think that's the right sort of version of that. I think it would have been language. Like, it's hard for me to remember which one is which. Stages. Lexer. I think here, this version of the Lexer. I've written this stuff so many times. Here's where I would have had my string parsing, and you see I have my own make string and make multiline, and they're basically the same, except this one, the multiline string, doesn't care if you have escape symbols. There's no escape sequences, they're just raw, except for obviously templates, just like Kotlin, for better or for worse. The only real consequence of that is if you're trying to write a literal $ in a multiline string, you have to do $, like something like this, which isn't ideal, but like, all in all, it's really not that big of a problem, I don't think. I mean, you could also just make a variable and then be like $var or whatever for like $D. Like, it wouldn't be the end of the world. But yeah, I'm like pretty happy with this design all in all. I've moved most things into this function. The only thing I'm doing separate is making string templates. And making string templates is honestly really simple. Well, if it's an identifier, right? All you have to do is ignore the $ symbol and make an identifier, and that's it. And because of the when statement, the when expression in Kotlin and stuff, it's so easy to just write this. And for the string expression templates, you see I recently changed this whether or not to make a new line, I just say false, because I don't care about new lines inside of this thing. None of them are meaningful because it's supposed to be an expression, not a statement. New lines only matter for statements. But yeah, it's just so simple. And even going on what I was talking about before, what I would have done previously when making templates is I would have checked if the next thing in the file is the end of file or a closing brace, I would have broken before I made a token. But here, what I realize is I don't care. I'm just going to make a token, and then I'll check. So for example, when I call make token, at the end, it's going to make a punctuator token that has a curly brace on it. But it didn't modify any state. So I can just not return that token as part of the result. I just can ignore it because it fundamentally doesn't matter. Like, I spent a little bit extra time hypothetically making the token. If you think making a punctuator is really like that complex of a thing, and then I can just ignore it and do nothing with it because I didn't change any state, because I didn't return the token, which is actually just so useful. It really just makes things so much easier, I think. And I'm really happy with the amount of progress that this functional style has. But as you can see, it's not pure functional, right? I'm not writing this like it's OCaml. This is very imperative and procedural while utilizing functional principles, which I really like. And you'll notice all of these functions are private. Literally, the only function in this file that is public is tokenized file, because that's the only one that needs to be visible to anything else. The rest of it is just implementation detail that can be private. Another thing I wish Kotlin had is file visibility level. Because when I say private, what I mean is it is private to the zenith.lexer package. That's why this isn't in the Zenith package, because I want all of these functions to be private, and I want result to be like zenith.lexer.result and stuff. Because in order to do namespaces, you need to do package. I'm not entirely sure how I'm going to work on module stuff in my language, but I'm sort of thinking about a lot of other languages, and I'm trying to make a good system. It's really just, it's the decision between, like, do I want to explicitly state packages? Because it's kind of convenient to have these faults not in a separate faults module, but just in the Zenith module. That's kind of convenient. But it's also kind of annoying to have to write the package declaration at the start of every file. And maybe it's just bad practice for everything to be in the same package too. I haven't really decided. But this is sort of the progress I've made so far. I'm experimenting with making the parser functional. So this is like a very early sort of draft of this. I'm passing around a context. You see here I have another result, which is currently a single node followed by none or more faults. I'm just trying to do the bare minimum of what I need. And how I'm representing things is I'm passing around a context. Now you will notice there is a variable in here that is some mutability, but my idea is, this is for convenience sake, inside of a function, inside of any given function, this variable exists. But what you do is, before you pass this context to something else, you call done on it. And what that does is it creates a new context that will then drop the previous tokens from the list. Because you don't care about the previous ones, you only care about the next ones. And so that isn't too bad in terms of performance, I don't think. Because at least the way it works with strings, if you call drop on a string, it will make a new string object, but the underlying array, at least according to ChatGPT, it's just going to give a new pointer into that array. It's not going to copy the entire array of characters. So what I'm hoping is the implementation for drop for list works the same way, in that the underlying data structure, it's not actually going to recopy, it's just going to make a new list object as a container that has a different pointer to something else, which shouldn't be too inefficient. But I still get the benefits of knowing that nothing else is modifying this context. But I still have some useful things. So I can say get, I can say next to check out the next token. I can then take it, or I can untake it because maybe I want to look ahead, right? And then when I'm done, I can just say done. And then however many I dealt with, it will just cut those away. And the next thing to have a context will have no idea what I previously did. I just have to call done manually every time, which is its own thing. I could maybe put that into like here, because I have two different results because I haven't really figured out how to do this. I need a final result, right, that I give to my main method. Wow. See, that's how like ingrained OOP is in my head. To my main function, where I give a node and I give a bunch of faults. That way I can just pass the tree as a single node and call it a day. But that's not enough information for all of these functions. They need to have that result, but they also need to pass the modified context, like I said. So I have a context result is what I'm calling it. It's essentially context and result, but I'm just calling it a context result. You pass the context, and I just have this convenient constructor so that you can just construct the result like in place here, where you can just pass a node in faults and then it will do the result thing for you, so you don't have to manually make a result every single time you make a context result. I again have convenient things for making warnings, errors, and failures with this fault label. And let me just sort of demonstrate how this process works. So instead of having a class to represent each of these nodes, I have one node class instead of an interface. And here's what it is. The way I'm storing nodes is they have a type, which I'm storing as a string. I might make it an enum eventually, but for now it's just a string, and this will represent what type it is, as you can see. Type being file statement, additive expression, primary expression, etc. That way, I have enough information so that I can call functions later. I could do like a type checker function. You pass it a tree. It can check the type of the node and then call other functions as necessary. That way, That way, that's how you kind of would do it in functional, right? You have to type match. Now, the way I was doing things before is each of my class, it could define its own properties for itself. The way I'm getting around that is I'm using a map of strings to faultables called children to represent the children. It has to be faultables because nodes, their children's could be nodes, which are faultable, or it could be tokens, which are faultable. And that way I have access to all of the children, but I'm using a map instead of an array so that you can index them by a keyword. So as an example, if I go back to my parser, up here where I'm making binary operations, this is its own sort of mess that I have to clean up with these parameters, but it's okay for now. As you can see here, when I'm making a new node, I can give it a type, and then I give it a map. And what I can do is I can say, okay, this left node is called left, this operator token's called op, this right node's called right. And then when I call a function on a binary op, I can anticipate it having these properties. Obviously that's up to me to sort of keep the names in check, but I think that's going to be okay. It's going to be better than making an entire class for everything, which is basically the same hassle. And so now I can just have a single node class, which is very simple, and I just make nodes as needed. Yeah, and so you can see with my basic idea, additive expressions can simply call parse binary operations. You pass the things that are necessary. Like, it's okay, the issue is it's just a little long, but also that's kind of my fault for using like the full additive and multiplicative words. But I just don't want to call it like a multi-expression because that feels like it means something different. I'll find a way to sort of manage it. But for now, as you can see, I'm just making numbers. And I'm simply just, like, that's the only sort of primary thing here, which is why ultimately, when I run this, or when I ran this, you can see this is what it produced. It actually worked well enough that it makes additive expressions multiplicatives so long as you have your numbers. But at the end, it failed, and because it didn't know the way I'm making these things, I'm constructing a file statement up here, which essentially just has a list of statements, which for now are all just expressions. Again, I have some mutable state up here. That's fine. That's just for convenience and efficiency, because I could do this recursively and adding immutable stuff, but that's just less efficient. It's not really worth doing. So long as I hide the mutable state in here, that's pretty good. That's pretty solid. Nothing else has access to this except this function. It's not passed anywhere else. It's not a problem. And so I'm not handling new lines yet, which is why it comes down to a primary failure. But something that is so superior to my previous versions. Previously, I was always calling an exception to be like, yeah, let's end the program. But now you see, even with the failure, I have this incomplete AST. I have this entire tree up to the point where it fails. That is so useful. Before, if it called an exception, it never got to the point where the tree was ever returned. The tree was never returned from the parser because I would have had to do it all the way up the way I am now. So what I said was, well, whatever, if there's an exception, you have no access to the tree for debugging. But now, when I'm debugging, if there's a failure, I can still see the tree, and I can see, okay, this is where the failure occurred. It's this final node here that it's a primary expression containing a new line. Yeah, that's wrong. So I'm happy. I'm pretty happy with this so far. I just whipped this up yesterday, and I still have to keep adding stuff. And once I add enough more like parsing functions, I'll be able to sort of extrapolate some of the other useful things I need to make into functions or data types to make this better. But I'm very happy with the progress of Zenith so far. Hopefully, if you're actually stuck around this long, props to you. My voice is actually like going. But yeah, that's basically it for now. I could talk a little bit about like my grammar, my numbers, but I think I'd rather just leave it here because there's a lot of stuff I'm not really finalized on anyway yet. Like my types and my memory management, that's all stuff I'm still sort of uncertain about. But my new functional implementation of this parser I'm actually pretty happy with. And maybe, I mean, once I finish this language, I'll probably come back and make tutorials on how to essentially make the entire thing, or like a subset of it, you know. And I think it will be helped with the fact that it will be a bit more functional, and maybe that will be interesting. I could make that even just a functional tutorial or something. Again, I'm using functional in a very, like, light sense. If I wanted to be more, I'd say it's more of a functionally imperative procedural way. That's how I'd want to describe this. Because if it were pure functional, it would be a lot of like, everything is something let, you know, which is Kotlin's version of basically OCaml, where you doing stuff like that. Look at pure functional languages, because this is completely different. This is very procedural and imperative, which I personally think is a good thing. And that's kind of the language I want to end up designing. But anyway, I've been talking long enough. I hope you guys are interested in this. I have to remember to add that link to that video, which is pretty interesting stuff. And I'll add a link to this repository, which is not in a good state. There's no README, there's no links to anything, but if you're interested in checking out this code, you can. But otherwise, hope you guys enjoyed. I'll see you in a hypothetical next video.